Hello, and welcome to Building Scalable Database-per-Tenant SaaS Architectures in Postgres with Neon and AWS. Today's webinar is sponsored by Neon and AWS Partner and produced by Actual Tech Media. My name is Scott Becker. I'm from Actual Tech, and I am excited to be your moderator for this fireside chat style conversation. Now, before we get to that great conversation, we have a few housekeeping items that are going to help you get the most out of this session. First off, we want this to be an informative event for you, so we encourage any questions in the questions box in your webinar control panel. So not only will we have team members responding to questions during the live event, but we'll also have a dedicated Q&A session at the end of the presentation where we'll discuss in greater detail some of the top questions that you ask. That Q&A panel is also the place to let us know about any technical issues that you might be experiencing. A browser refresh is going to fix most audio, video, or slide advancement issues. But if that doesn't work, just let us know there in the Q&A and we'll provide further technical assistance. Now, second, in the handout section of your webinar control panel, you'll find that we're offering several valuable resources. I'd especially like to call your attention to a PDF on scaling your multi-tenant SaaS with Neon Postgres. At the end of this webinar event, we will be awarding a $250 Amazon gift card to one lucky registrant. Of course, you must be in attendance during the live event to qualify for the prize. Official terms and conditions of today's prize drawing can be found in the handout section. Just scroll to the bottom and you'll find the link with the details there. Now, finally, one of the best benefits of this opportunity or of this event is the opportunity to ask a question of our expert presenters and to help encourage your questions. We have a special additional prize for you. It's another Amazon gift card, this one for $50 for the best question. After the event is over, we'll look at all the questions that came in, pick out the very best one, and contact that prize winner. Okay, with all that housekeeping out of the way, let's get into it. So, adopting a database-per-tenant architecture can be advantageous for many SaaS use cases, but at scale, these architectures tend to become costly and challenging to maintain. So today we're going to have a fireside chat to explore practical strategies to navigate these hurdles with AWS, Retool, and Neon. So Himanshu Bando is here from Retool's engineering team to share firsthand insights on how they manage hundreds of thousands of Postgres databases with minimal engineering resources. Then to unpack the serverless architecture that underpins this scalability, we've got Ralph Chebri at Neon and Bill Tarr from Amazon Web Services. So all in all, it should be a great conversation, hopefully showing you the key elements to consider if you'd like to build a database-per-tenant application yourself. So Ralph, Bill, and Himanshu, welcome.
Good to be here.
Hi, everybody. Very excited to be here.
So
Happy to be here.
Oh, great. So to start us off, maybe we could each, you could each tell us a little bit about yourself and your role. Let's start with Himanshu, then go to Ralph, and have Bill go last, but of course not least.
Hey, I'm Himanshu. I'm an engineer at Retool, and I'm part of the team that manages Retool DB, which is our out-of-the-box Postgres solution or feature, which is powered exclusively by Neon.
All right. Yeah. So I'm a developer advocate at Neon, and what I do, I basically talk to developers, go from events to events, and learn from developers and what they do on a daily basis, and also talk to them about the great things that we do at Neon. So that's it about me.
Great. Well, yeah. Hey, everybody. My name is Bill Tarr. I'm a principal partner solutions architect with AWS SaaS Factory, which is a giant mouthful of words to say that I'm a SaaS evangelist. I like talking about SaaS, describing the different aspects of how to build SaaS on AWS. And I'm really pleased to be here to help to position how Neon can be an important part of a developing SaaS stack on AWS.
Awesome. Well, thanks to all three of you again. Delighted to have you all on. So, Bill, sticking with you, I wonder if you could walk us through why this topic of database per tenant is interesting for scaling SaaS and platforms.
It's a really important point. Let me show a slide really quick here. Anyone who's seen our slides before has probably seen a slide like this from our team. Because when we talk about SaaS, we often start by positioning how we deploy SaaS and how we manage isolation within SaaS. And as you can see from this slide here, this is a full stack deployment, right? So when we talk about deploying full stacks, you're probably familiar with stacks if you're a developer, right? You've got some sort of web application sitting at the front end. You've got some services with some business logic sitting in between. Eventually, things are going to land somehow in a persistent storage, right? Like a database. What that looks like in terms of how our customers in SaaS use those is really one of the first decisions we have to make about how we're developing SaaS. So this is just a very simple demonstration of sort of the polar opposites of how you might deploy a SaaS application. You might deploy a complete stack to each one of your customers, which we usually call tenants when we're talking about SaaS. So what this visual here shows is each one of our tenants, tenant 1, tenant 2, each getting their complete own stack. That means they have their own web application architecture, their own services in between, and of course, their own database. There's a lot to like about this stack, but it's not the only choice, right? When you're deploying SaaS, you're also trying to get to a most cost-optimized solution possible. So we also see customers going for a pooled solution as well. In other words, all of your tenants get a shared stack. So you don't have your own web server, you don't have your own services. At runtime instead, we're making decisions about how to best navigate through those services based on the identities that are passed in. Now, if we're going to describe the differences between these two, in the silo stack, which is what we call when each of us gets our own complete full stack deployment, it's relatively easy to manage isolation. These might be their own AWS accounts. It might be their own AWS VPCs. Regardless of what that isolation mechanism is, it's strongly in place from a networking perspective. And the data at rest is naturally going to be completely isolated from other tenants or customers' data. As a startup, there's a lot to like about making that choice. And in terms of simplicity, in terms of compliance and regulation, a number of other cross-cutting concerns, we often encourage startups to go in this direction unless they have a lot of existing experience building a shared or a pooled stack, which is what we see on the right-hand side here. So as we're thinking about these stacks and the decisions our customers have to make as they're building SaaS on AWS, increasingly we're talking about shifting toward a silo stack, especially early in the process. And if you're developing an application today, that silo stack probably looks a lot like what you're already deploying to your customers, right? So if you're already going down this road and building an application, it's really not a huge jump to go from I've got an application and it stores something into a Postgres database to, hey, I can deploy multiple versions of this application. There's still a lot of things I would talk about with SaaS customers about how I would encourage them to build best practices in. I don't want to see multiple versions of this application. So even though we're developing the application and deploying out to multiple customers, we still want to maintain the same version. We want to have the same database schema. And any changes we make to these different customer versions, we want to be done by configuration over customization. But regardless, as we're thinking about how we get down to the data side of this stack, even if you're building a pooled solution, it's not necessarily a given that you're doing full stack deployments. So that silo application we were just talking about, where everyone gets their own services and their own databases, could be changed to represent in a picture like this, right? All of your databases are singular to a single tenant. Even if you're developing a pooled architecture, which again, if you have the capabilities to do so, can be advantageous from a cost perspective, you could still have your data at rest completely siloed. So this simple choice between a silo and a pooled stack doesn't necessarily mean that your data also has to follow the same choices as your compute stack. And we often see these mixed stacks when we talk to early stage customers, because what they recognize is the customers that they're trying to sell to require some isolation, or they're coming to them with these requirements right out of the gate saying, hey, we're an enterprise customer. We're not really worried about how our data is in transit as long as it's encrypted and as long as it's secure. But when it's at rest, we expect our data to be completely siloed and isolated from our competitors' data. I don't want to have any possibility of our competitors' data and our data being commingled in any way. So this is a common requirement startups run into very early in the process. And if you're doing B2B SaaS, if you're selling to large enterprise customers, there's increasing concerns in this area of around isolation. Increasingly, we're seeing enterprise customers come and saying, all of our data has to be siloed at rest. We have to be able to apply different regional compliances to that data. We have to be able to prove that that data is staying in region. We have to prove that that data meets our requirements that we have set forth, whether we're following SOC 2, whether we're following HIPAA, FedRAMP, whatever we're following. It's much easier for us to describe the compliance story of this data if it's completely siloed. So, I mean, that's a lot of stuff to pull together, but at a very high level, this is how we think of the data. And when we get down to this compliance story, it can get even more specific. If you're doing a specific database per customer, especially if you can pull your data apart and identify which is your most sensitive data, having that in a completely siloed data source. And in this example, it's relatively simple, right? We've got some patient data. So maybe we're trying to apply HIPAA compliance rules to our data. We might want to have that data completely siloed, at which point it brings us to the question of like how we do this, right? And managing all of these databases, managing all these instances of Postgres is relatively operationally complex, right? If you go in and start to have hundreds and even thousands of individual instances of Postgres databases, that puts a big burden on your team. And that burden takes your team away from delivering functionality that your customers want and maintaining that agility and flexibility to continue to release innovation and features to your customers rather than focusing on how you manage tons of databases. So this is really where I think talking to customer partners like Neon, who have solutions who can help to simplify the management of siloed databases or database-per-tenant, really helps to facilitate the conversation for startups who are trying to build SaaS solutions and trying to get to market as quickly as possible and manage all of these tenants and customers that they're hoping are going to adopt their solution without becoming simply a shop that manages those solutions and instead continues to focus on innovation.
Okay, fantastic. So a lot to think about there, laid out a lot of clear advantages for privacy and compliance, but raised some challenges too, especially around managing all those instances and controlling expenses. Ralph, how does Neon help its customers take advantage of the benefits while navigating those challenges?
All right. Actually, yeah, I would like to share my screen in order to answer that question.
Okay, great.
Hold on, just give me a second, and let me know if you can see this. You should be able to see. Yeah, can you see my browser here?
Yep. Yeah, we see ship faster
Yeah.
with Postgres. Yep.
All right. Yeah. So let me take a step back and talk a little bit about Neon. So Neon, as you can see on the website here, is a serverless Postgres. And you can see here that it talks about scaling your instance up and down, and it talks about branching, and we can discuss that a little bit later. But basically, those capabilities give it some interesting some interesting scenarios where you can provision multiple databases very fast, and you can provision databases per users. And Bill talked about having a pool versus a silo model. So let's discuss that a little bit. So with the pool model, basically, what I like about it is that it's quite simple, right? So you have your application that is connected to a database. You send your queries, you get your data, everything is great. But the problem is at scale, right? When your database starts to become quite big, your latencies might get slower, etc. So you might want to have a different model, and there are also solutions out there with sharding, etc. And for that I have a quick example to show you, but let me find it first. So many tabs opens and so many screens. All right, so I have this little application here, which is just a chat with PDF application. So I have a document here that I can upload, and here it talks about mixture of agents as one of the papers that I found that I wanted to know more about. And what I can do is chat with this application here. So the first step is to upload the document, and when you upload it, if you're familiar with retrieval augmented generation, the text of that document is going to be split and then saved in the database in forms of rows, and those rows are going to be composed of text and also of vectors. Let me show you an example of that here. So this is the Neon dashboard, and here I have my text here. So every time I upload the document text is going to be chunked. So I have the text here, and I'm gonna have like some vectors embeddings here. So and the whole point is, at some point, when I'm going to chat with my PDF, so when I'm going to ask my question, and here I ask a question, what's mixture of agents? What's going to happen is it's going to run a query that is similar to this, or what we call a vector similarity search. And these are, in short, they're heavy calculations. And here I'm using actually kind of naive approach with setting off index scan. Just to have like a sequential scan, just to show you like how slow it can get, because I have millions of rows in this particular database. And this is kind of unacceptable, especially if you have, the kind of SaaS application that requires low latencies, and if you want to, if you care about user experience, then these kind of latencies are not good. And obviously, this is a naive approach. I'm not using any index, and you can use an index and get the latencies quite low, but you're not going to solve all the problems that are related, with having one single pooled database and a pool model. All right, let me get back to my slides here. And this is about RAG. So the application that I showed you was using, a pool model. But if you want to turn it into an application that uses one database per tenant, it would look something similar to this. And you would have your client application, you would have your backend here, and you would have like some sort of proxy that actually can translate those queries and user IDs or DB hosts into connection strings, and can communicate directly with the database and return the data that you're looking for. And here I have multiple databases, and I told you about the ability of Neon of scaling up and down. It actually has also the ability of scaling down to 0. So the nice thing about this is that if you have customers that are not, connecting on a daily basis, then those databases are just gonna be shut down. The storage is always going to be there, but at least the compute is not running anymore. So this is one architecture, and I'm going to show you an example of this when I'm using DB host, so the database host that I'm passing to the proxy. But also you can imagine other scenarios where you can have, you can communicate with the database directly. So if you want to have a more secure solution, maybe then you can pass on, the user ID, just like you would do it with any regular application. And in this case, you would communicate with a database that would have that mapping of DB host and user ID. And you can think of a solution where you have maybe a cache also, so to reduce these kind of latencies, and then query your database from there. Another example also is actually not to use any database, not to store anything that is customer sensitive, and use the Neon API to get the database URL in this case, and also query the database. But we can talk about that a little bit later. Now, I just wanted to show you like the second version of my chat with PDF application. And in this one, let me actually sign up and show you. Oops, no, not here. I'm signed in, but here I want to sign up. So I want to create an account quickly and show you what it does. Oops, no, that's my email. There you go. And I'm going to call it Rav Shabri. And I'm going to give it a very secure password. And before I hit sign up, I wanted to show you the Neon console and show you what I have in my database actually. So this is what the Neon console looks like. And here I have two types of projects. And for us, a project really is a Postgres cluster, just like it. Just think about it as an RDS instance that is deployed. It's not really the same, but you can think of it like that. So here I have my database, which is my centralized database where I have all my users. And if I go to my tables here and I look at my users table, then you can see this is an account that I've created before. And if you look at the list of projects that I have, so you see this weird project with 35DE. This is actually the user ID that I have here for my previous account, but I have an entire project, so an entire database that I can identify like that. And here it just has like a bunch of documents that are saved here. So once I create this account here, let me sign up. What it does, I can go back. I'm sorry for going back and forth. So not only I'm creating a new customer in my database, but I'm also created another project right here. So you can see this B94, and it's right here. And it really took a matter of less than a second to create this project, because we have this ability of creating them on the fly, provisioning the databases really quickly, and maybe I can even look at the operation somewhere, and maybe I can find. I actually created it in less than 3 seconds. But yeah, but you see how fast you can create databases as you go, and as you sign up more customers to your application. All right, and I just wanted to quickly walk you through the code and show you how that was done. Basically, here I have my backend. This is written in JavaScript, in TypeScript, and what I have here is the part where I create a user ID. And when I create a user ID, so before inserting into the database, I create a project. I create a project here, and the code is like this. So all I need is an endpoint, and the endpoint is console neon.tech API v2 project, and also I need an API, a Neon API key. And it's as simple as that to actually create a database. And once I do that, I can get the host, the project ID, I can get the connection string if I want, and I can get a bunch of other information. And at sign up, also, what I do in this case, I return the project ID, and I also return host. And every time I query the database, so when I try to retrieve my documents and ask questions about the documents that I uploaded, then it passes on the host ID, the host, and then it knows which database to communicate to. Yeah, so that's it for me. Yeah. Back to you.
Great. All right, super. So, that's a perfect segue to Retool as a customer of this platform. So, Himanshu, would you tell us a little bit about what Retool offers, to your own customers, and why that made you interested in Database-per-Tenant at scale, as well as how you built your architecture?
Absolutely. Yeah. So at Retool, we run a fairly large fleet of Postgres databases, and we use Neon for that, and essentially relying on Neon APIs exclusively for that. So essentially, we provide one database per organization, which maps typically to a user that signs up on Retool on cloud. So I'll dig more into that, but before that, I'll talk about what Retool is. So Retool is an internal tools builder product. So building internal tools is not fun for engineers. With Retool, you can easily drag, drop components, buttons, etc., and be able to connect to your database, APIs, whatever you like. And we have 50 plus integrations. And yeah, essentially be able to build fairly good looking utilitarian apps that otherwise would have taken a fairly long time. We have a bunch of quite successful customers using Retool for a while now. So going on to Retool DB and Neon and Postgres. So for the longest time, users who would sign up onto Retool on cloud would have to set up their database, bring their own database, set it up on Retool, and then be able to build apps using that, which took a lot of time and took longer than we would like to get to value. And we would see a lot more churn as a consequence, because like if we ask for so much before we get to value, that then work well with customers, so, or users rather. So yeah, the solution there was Retool DB, which is we provide one Postgres instance per user on sign up. So whenever you sign up, you can go and sign up and you will get this Postgres instance. And under the hood, it's actually using Neon. So our requirements for this was easy management for us. We didn't want to deal with all of the DevOps challenges and like infrastructure and maintenance that comes with managing a large fleet. And when I say large, it's at peak it was 400,000 or more. So that's fairly large. And in terms of the eng expense for us, at least, like while using Neon, we have at any point in time more or less like one engineer working on this, which is huge, frankly, for us in terms of how much savings we have in terms of eng time on this. Another piece was, since we're providing this to each user or each org on sign up on Retool, we'd see essentially we create a lot of databases or database instances, but some users would churn, some would come back after a week or a few days, and basically we wouldn't expect usage to be constant. And for us, that meant that like with Neon, we would get a huge cost benefit because we wouldn't be paying for compute on an ongoing basis for idle projects. So at any point in time, if I had to estimate, it's more like 95% plus are like projects are unused at any point in time. So like that is quite a big benefit to us. Lastly, scalability. So obviously, as I mentioned, like with 400K plus projects, like this platform had to be scalable. Neon is, so that works very well for us. Another part of scalability is scaling up. So certain set of customers, like paying customers, may ask us for like maybe more storage. Or maybe more connection, like bumping up the connection limit in the connection pool and so forth. So that is also something that is easy to manage with Neon APIs. And so again, we don't have to spend much time on it. And I'll go further into how we manage that next. So yeah, talking about Neon, as I alluded to earlier, robust. It has a great API, which has worked very well for us. Idle databases scale to 0, so we're not actually paying for compute on an ongoing basis for idle databases. And yeah, it scales up very well. So yeah, this one. So this is about how we manage the fleet within Retool. So yeah, the fun fact is that we use Retool to manage our entire fleet. So what does that mean for us? So we have this app where for any organization, you can see the, let's say the project that's assigned to them on Neon, and we can see the quota. So if there's a request that comes our way from, let's say, support or from the customer for asking for more of like a quota bump, our support staff can easily go to this app, like bump it up, and no engineers would be involved in this process. We'd log the state of like all changes so that we at least have some way to go back and look what happened. But it works fairly well. We also can see for any project, we can, again, make a request to the Neon API, fetch activity history, and be able to see when compute was started and like shut down, etc. So it's fairly transparent. We also have, this one's not shown here, but we also track our billing with Neon on Retool to be able to track how we are trending. So yeah, overall, again, like low maintenance for us. We have these apps that essentially make it very transparent and easy to manage Neon. Yeah, that's about how we use Neon.
All right, super. Well, man, that's certainly a compelling scalability story. 400,000 databases. That's amazing. So, Ralph, coming back to Neon, why is it different from other PostgreSQL solutions that are already available in AWS?
Right. This is a very frequent question. Like every time we talk about these kind of capabilities, people ask us the question like, how do you guys do that? And we always need to take a step back and sometimes, talk about the architecture. I actually have some more slides about that if that's okay with you guys.
Oh, great.
Let me just share my screen again. And Yeah, this is, well, like, I think Himanshu addressed, some of the advantages that you have with Neon, and with the silo model that we propose, right? So you have a complete separation of the data, and Bill touched on that. You have possibility of having a reduced query latencies because of you're dealing with small databases, multi-region as well. You can have instances in different regions, and also it's we haven't spoken about data recovery, but I'm going to address that. I'm going to talk about one of the features that make Neon very different, and also reduced cost because of that ability of scaling down to zero. Obviously, if you're this is not a perfect model. So if you're a startup, for example, and you want to move fast, maybe that's not a right approach for you. Although, like, the API makes it quite easy to have a silo model, but maybe you just don't want to learn anything new, and you want to move forward and not add the extra complexity and having multi-version in support in your SaaS application. So that's totally fine. You also need to deal sometimes with the cold starts, and we're going to talk about why we have cold starts. And also, one of the cons also is if you have, since you have fragmented data and you have them in multiple databases, then you cannot have one query and do analytics. But you can always stream that data in a centralized system and do those analytics queries later on. So what makes a Neon kind of unique? And again, I'm going to just take a quick step back and talk about regular Postgres. So usually when we talk about scaling Postgres, you'd have something like this. You'd have like a primary database that uses local disk, and you also probably would have replicas, to serve more of your customers. And also, it's very important to have a backup system, and probably you would have some sort of cloud storage where you're saving backup and vault. Maybe you have extensions that do that too. So when we thought about creating Neon, we were like, why can't we have all of that, in one single instance? And this is why we came up with this architecture. And this tells a lot, but mainly Neon separates storage and compute. And on the left side, you can see Postgres. And for us, Postgres is just, it's a stateless instance. So it doesn't save any data locally. But what Postgres does for us is that it stores data in our storage engine. So that storage engine is multi-tenant, is created in Rust, and it has different parts. And let me walk through those, but we discussed also like why this is beneficial. Since Postgres is stateless, then it can shut down, and your data is not lost because it's in the storage engine, and it reduces your compute cost. But since we also have one storage engine, then you can have multiple read-only nodes that read the data, from one single source, and you can ensure consistency in this case. And also, the compute nodes scale independently. So the nice thing is that we have an auto-scaling feature, and we just allocate more resources to one instance if we want. So let's say that you have a sudden peak in load in one of the instances, that instance is going to just allocate more resources, 2 CPUs, 4 CPUs, etc., dynamically without you worrying about it. And also, we store everything in S3 as well to make it durable, but also to try to reduce for cost. All right, so I spoken about the different parts. I spoke about Postgres. So for us, Postgres is just a stateless instance. We also have what we call safekeepers, and this part just makes the data durable. So it uses Paxos as a consensus algorithm to make sure that the data is never lost, since it's a distributed system. And then most of the magic happens in what we call page servers, which are which is our main component of our storage engine, which knows how to reconstruct any data from write-ahead log records. So here, what I haven't explained is that when Postgres saves data, so in Neon, it streams write-ahead logs. So it streams like the history of the database. and it saves those in our page servers, and then the page servers read those that history and gives you the answer to your query, which opens up scenarios like time travel queries and branching that I'm going to show you an example of. Actually, yeah, and if we talk about the entire architecture, so we also have a proxy and a control plane. But let me actually show you what point-in-time recovery looks like, or just the branching feature in general. All right, so I want to go back to this particular example. What I have 18 gigabytes of storage, and if I want to create a branch, and a branch is just a copy of a database, right? But for us, it's a copy on write, so it's just a pointer to a certain timeline. And let me show you, when I create a branch, I can create it from any point in time of its history, of the retention period. So the history is kind of subjective here, because I think you can have 7 days, you can have 1 month if you want, but so within that time frame, you can create a branch, or you can recover from any point in time. So here I'm just gonna keep it as current. I'm gonna give it a name of test, and I create a branch, and you see it takes 200 milliseconds, 500 milliseconds. So it's almost instantaneous for us to create a new instance and deploy it, and you get a connection string. You can connect to it, and you can use it. And the nice thing about this branch now, it has exactly the same data as I had before, so I can query it just like I queried it before. Let me look. Yeah, and I have my test branch here. I have my main branch, and I have another branch here. So and it shares the same history. But once you start writing in it, then that's where they fork. Just like what you're used to if you use Git branches, for instance. So yeah, so that's what makes Neon, I'd say, different from other Postgres offerings. Also here you can see that, and I didn't show this, that my primary compute has auto scaling, and it scales from 1/4 of a CPU to 10 CPUs. So I don't have to worry about about scaling my application if I have some peaks for any reason. I can change this as I want. I can fix it also to a certain amount and not use auto scaling, or I can say I want it from 2 to 4, etc. So yeah, those are the main differences, I'd say, and what makes Neon kind of unique.
Okay, excellent. In Bill, I've got a follow-up for you as well, based on Himanshu telling us about Retool's experience at scale. That was a big use case with the 400,000 databases. Could this architecture also benefit smaller startups building like B2B SaaS? In other words, is this a good approach if you don't need hundreds of thousands of databases?
All right, it's a great question. I think one of the things we talk to SaaS startups a lot about is thinking about what they need at the stage they need it. And I'll bring up another slide here that I think is kind of interesting. If we think about how startups function and how they think about what they're building in SaaS, they go through a series of phases. Startups are very focused on this, right? They're very focused on how to get to product market fit. Like, how do I go from launching this product, the ideation phase, into actually implementing and then finding the product market fit and really starting to scale it. So what you saw with Retool is something that's scaled fantastically, right? They've got thousands of databases, but there are some steps before that. And kind of the nice part here, if I think about it as holistically, I didn't make this slide for startups. I actually made it for all businesses who are thinking about how they're going to build a SaaS product. Everyone who's building a SaaS product should be evaluating it in the same way. How do I get to product market fit? How do I find that I've built the right thing before I actually start to scale it and try to spin this up for hundreds or thousands of customers? Or else we're going to incur a lot of technical debt around the things that we've built, and we're going to have to go back and revisit those decisions. So I want to highlight a couple of things we've talked about today. We talked about how to choose an isolation model. Like you have to pick a silo or a pooled model. You want to ensure that there's strong boundaries around those. And I think if you think about some of the things that we saw today in terms of what Neon does, those strong boundaries, being able to use APIs to make decisions about which database to use, about how to change those databases, some of the things that Retool is really taking advantage of to scale their platform would be valuable to a startup who's just finding their first 10 customers, or an enterprise who's trying to build out to 1,000 customers very quickly because they've got an existing product. Being able to test those tenant boundaries. Also, again, Retool's ability to have an API-driven approach allows you to easily test these different models, right? We always talk about frictionless onboarding. How do you take customers and spin up their environments as quickly as possible so that they can obtain value? The same applies to testing. How do we create testing environments that map to our production environments? That backup feature we just saw is a really powerful feature to be able to test actual production environments and create testing environments where we can prove that the isolation that we've created around those databases is sound and resilient. Now, the last thing I have on here as you're starting to scale is those isolation choices are what we call a two-way door, right? If you decided, hey, we're only going to build silo in the beginning, so we've used Neon and we've created a database per tenant, we can still go back and easily with Neon revisit those decisions and create pooled solutions even on top of Neon. So the fact that we've got a back-end solution for our database that's flexible means that even though I want you to early, as you're thinking about your product early, pick an isolation model, do that, really nail that one, ensure that the isolation is in place. Often that will lead me to talk about silo initially with customers. Regardless of which one you picked, you can still go back and revisit those decisions, because as you're starting to grow, you'll find customers with different needs. Even if you designed only for enterprise customers in the beginning, you're going to probably find long tail customers that are going to demand lower cost versions of your solutions, and you're going to start to develop more pricing tiers, right? Having a back-end solution that allows you to do those without having to go back and reinvent everything you've done is a really valuable piece of your stack. And a few of the things that you saw today out of Neon and how it can enable you to do these things through APIs, through one-touch backups and creating branches off of your data, and allowing you to actually create these databases through the API and spin them up quickly, really give well to a SaaS solution, regardless of whether you're a startup and thinking about those early stage customers, all the way up to the largest enterprise customers who perhaps are even building SaaS solutions for their internal audiences, which I think also goes back to some of the things Retool talked about and how they build solutions for internal customers. So you've probably heard a lot of interesting things for anyone who's thinking about building SaaS, and how Neon can be an interesting part of your stack and help remove some of the undifferentiated heavy lifting, regardless of where you are in your journey here.
Absolutely. Excellent. Gentlemen, so far this has been a great conversation. We haven't even gotten into the questions yet. We've got quite a few questions coming in from the audience. Manchu, this first one I think is for you. So they're wondering, do you ever have to handle schema migrations across the entire fleet, and how do you handle that?
That's a great question. So there are some occasions when we have had to do that. It's less of schema migrations, more of like installing extensions for use cases. Like we have Retool AI that again uses Neon, the PG Vector extension. So we've not had schema migrations as such, because users typically perform migrations by themselves because it's their own DB. But for large scale sort of operations like these, we've had to iterate through like databases and perform whatever operations we've wanted to. So that's how it's worked so far.
Okay. All right. Excellent. Ralph, a couple of questions here look like they'd be for you. Somebody's wondering, how's Neon's latency? The person's worried due to S3 storage and cold starts.
Right. So when you talk about latency, you can talk about read latency and write latencies. Again, Neon is a distributed system. So when I showed you earlier the safekeepers, the part of the storage engine that makes the data durable, and that uses a consensus algorithm. So when you write data, it has to go through that through those nodes in order for it to acknowledge the written data. So it doesn't take long, but it's definitely not as fast as standalone Postgres, but it's as fast as it gets when it comes to distributed systems. Read latency has actually become really interesting because we have a sharded storage engine, and if I'm not wrong, I think we shard the data into, I think, 128 megabytes. I'm sure one of our engineering, our engineers is going to correct me at some point. And because we have that sharded architecture, that makes actually throughput and latency is quite low when it comes to reads. So you wouldn't find a big difference with standalone Postgres when it comes to reads as well. And you can always have also techniques to cache the data at the compute level in order for you to reduce latencies in that sense.
Okay. All right. Great. Another one for you. Somebody's wondering, what are some practical applications of branching? How do you see SaaS startups adopting that?
Yeah, we see different applications of branching, and I think so. The most obvious one is for development, right? Like, you want to test your application or your new feature against real world data, and branching solves that problem. You can just branch out whatever environment that you have and test against real data. So that's or build your feature against real data. So that's one scenario. Another interesting scenario is having it in your CI/CD pipeline, because it takes us less than a second to create a database. So it becomes really interesting to test against a branch of your database instead of compromising an existing database. So when you have a staging database that is unique, you might have a big team of developers developing features that could have breaking changes. And because of that, like, if you're using the same database, then you might find yourself in a position where you're breaking someone else's code. But with branching, you can have different versions of the same data that you can modify without compromising the main environment. So that's another scenario where we see people use it. Another very interesting scenario, I don't think this is very common, but one of our customers actually use it for scenario analysis. Unfortunately, I wouldn't be able to go to details, but basically they branch a particular instance and they test different scenarios. So they modify the data that is contained in those databases and try to and analyze the output of like a certain algorithm based on the data that they modify. So yeah, we see some interesting scenarios out there, but I'd say, like, managing your environments for development and testing are the ones that we see the most.
Okay. All right. Excellent. Ralph, I'm going to keep you in the hot seat for one more question, and then I promise I'll spread some more around. We've got a question. What's the maximum size possible for a single database?
I think currently, if I'm not wrong, we support up to 2 terabyte per instance. And that's that's something that we're gonna have more capacity very soon, where we have a great team of engineers that who are very conservative in their estimates. So they like to walk slow, and when we announce something, we make sure that it works really, really well. So we're quite confident with 2 terabytes, even though if theoretically we can have more. But yeah, that's the size of one instance that you can have.
Okay, excellent. We've got a question here for Bill. Which advice or resources would you recommend to a young SaaS startup planning to implement a silo architecture? So they're saying the benefits sound attractive to them, but their team is still new to managing infrastructure at scale.
Yeah, I mean, it's an interesting question because there's a lot of different places I'd point you. So one, obviously, enabling your team, especially if you have a DevOps team, is where I would start, right? If we have lots of resources with the SaaS factory, we've built reference architectures on how to build a control plane, how to manage SaaS on EKS or AWS serverless. So if you're looking to manage all of your own infrastructure, that's a great starting point. But I would be remiss if I didn't mention AWS partners. So Neon is obviously an AWS partner in the software path who's built a great tool. We also have partners on the solutions integration side as well. So we have SaaS competency partners who can help you to understand how to build SaaS, have built SaaS with lots of our other partners, and can help steer you along the way to, avoid some of the common pitfalls for how you would build SaaS. There's going to be some things. If you're going to build a silo infrastructure, you might have to have multiple AWS accounts. How do you manage those accounts? Do you use organizations? Do you use control tower? There's different solutions that you might only ever have to set up once, right? So you don't want to get into the business of learning how to do those, just like you don't want to get into the business of managing thousands of individual Postgres instances and how you do backups and how you think about upgrades and everything else when you can let a partner do those. I also don't want you to be focused on the undifferentiated heavy lifting of learning how to build a SaaS product and some of those pieces of infrastructure, like infrastructure as code, that you might only have to do once. You just really want to focus on the parts that are relevant to your solution and deliver those. So you're, again, focusing on value to your customers rather than focusing on the undifferentiated heavy lifting of building on AWS.
Okay. All right. Fantastic. Himanshu, here's one for you. Somebody's wondering, do you use any other AWS infrastructure, and how is the process of integrating Neon into that?
So all of our stack, or like all of our infra, is on AWS. And so sure, like our main backend DB and like infrastructure, sure, uses AWS. So, but then the state of like Neon instances, so mapping of cloud organizations to their respective Neon instances, that's managed or persisted on this backend DB. So that's how we manage who owns what, and when they're using Retool, what database they connect to and fetch from, etc., and like what connection string we would expose for any organization. So yeah, that's how we manage it. And sure, the parts around like the meta of like how we manage the fleet I already covered. Yeah, I think that's essentially what we do currently. Yeah.
Okay, excellent. Yeah, there's another question here for you. Somebody's wondering, what are the best practices for managing such a huge fleet of databases? It sounds like you guys have it pretty dialed down with, what was it, 400,000 databases with generally one software engineer, at a time?
Yeah. So that was at peak. Yes. Yeah, like for us, we do have observability on how users are, like how queries are faring. So on Retool, as you talk to Neon, like as a resource, we would track failure rates for queries or like the errors that we see. Sometimes that may drive us to take action, maybe bump up certain pieces of the quotas or like settings for any instance, so that we lower the error rates for any such orgs. But in general, the general answer is we have observability on that. We also have, as I shared earlier, this Retool app that helps us see exactly, sure, who owns what, like maybe like when the instance was spun up, etc. Essentially some like logging state of how any instance is used. That's more like point solution where, like, let's say a customer user like comes up and maybe was having issues connecting or has some issues with the instance. We would look at where things might have gone wrong and at least like help triage and like fix that. So that is what we've been doing so far. And that's worked so far. Also, it helps, like, since we have such a large fleet, Neon actually helps us out a lot in terms of again, debugging, or if there's any like performance issues, maybe connecting or the connection pool management, etc. So those are things that we rely on Neon for. So we have an active sort of relationship there, and we work with them, and that's been very fruitful and very helpful as well. Also, as I talked about earlier, Neon APIs help a lot as well. So for any bulk operations, we extensively use Neon APIs for those. So we have a bunch of scripts for a bunch of different operations we've done in the past. And that's worked out quite well as well for us. We rarely, if ever, run into issues with Neon APIs as we build any of these scripts or run any of these operations. So yeah, that would be my answer here.
Okay, excellent. You know, and Ralph, one for you. Somebody's asking if you can share any scripts. You know, and I think that question came in during one of your demos. But you know, are there repositories that you guys provide to customers? You know, or where can they get their hands on some of those kind of things?
Yeah, so the example application that I showed is present on the repo, but yeah, I'll need to modify it a little bit and submit the new code that I have. But I think we have also, I have a colleague, Mahmoud, who's working on a demo that is going to come out very soon, where you can have when you can have a database-per-tenant or like a silo model out of the box with that example. But we'll make sure to share it very soon.
Okay, all right, excellent. Well, you know, I hate to say it, but I think we're up on time. We had so many questions here. This was fantastic. You know, so much interest, such a great presentation. You know, I just want to thank you know, all three of you for just a fantastic presentation, and thanks for this discussion. Really, really appreciate it.
Awesome. Thanks for having us.
Absolutely.
Thank you.
Yeah, our pleasure. All right. Well, I'm going to let these guys go, and we'll just move into our last piece of business, which is the prize drawing. Sorry, I've got too many windows open. I'm just moving things around. So it is time for our Amazon gift card prize drawing. And the winner of the $250 Amazon gift card is Scott Brissenden from Texas. So congratulations to Scott Brissenden. We'll get in touch to get you your card. And with that, on behalf of the Actual Tech Media team, I want to thank Neon and AWS and Retool for just making this event possible. Thanks as always for attending and for your great questions. That's going to conclude today's event. Have a fantastic rest of your day.